welcome to the Deep Dive. Today we're looking at something pretty fundamental to how our tech works, but maybe not something you think about every day. Software interoperability testing.
That's right. We've got some material explaining how different software systems actually manage to, work together seamlessly.
And the core question we're tackling is really, how do we ensure all these different software components and systems can effectively communicate and function together without all those compatibility headaches?
Exactly. So the sources we have really break down the concept and the process.
Right. So our mission here is to pull out the key insights. Why is this testing so vital? And how is it actually approached? We want to give you a clear picture of this important slice of software development.
Okay, so first things first. What is interoperability testing exactly?
Good question. Lay it out for us.
Well, simply put, it's all about checking if software can interact properly with other software components and systems. It verifies that end-to-end communication works as it's supposed to. Think about like sending a photo from your smartphone to your tablet using Bluetooth. That smooth transfer, that's interoperability testing paying off.
Right. That everyday example makes it click. So why is it so important then? Why put in all that effort?
Well, for one, it guarantees you get that complete service experience, even if you're using products from totally different vendors.
So mixing and matching tech.
Yeah, like maybe you have a fitness tracker from one company and a health app from another. Interoperability testing is what ensures they can, share your activity data without any glitches.
Makes sense. It stops things from being totally siloed.
Yeah.
What are the risks if this testing isn't done well?
Oh, the downsides can be pretty serious. You could face data loss, which is never good.
Definitely not.
Or unreliable performance things, slowing down, crashing, even incorrect operation where the software just doesn't do what it's supposed to do correctly. And longer term, it makes maintenance a nightmare.
Right. Sounds like a recipe for user frustration and worse. Now, the sources mention different levels of interoperability. What's that about?
Yeah, think of it like layers. At the base, you've got physical interoperability. Can they even connect physically?
Okay, the basic connection.
Then data type interoperability. Do they understand the format of the data being swapped?
Like is it text? Is it numbers? That kind of thing.
Sort of, yeah. Then specification level. Are they both following the same agreed upon rules or standards?
Got it.
And the highest level is semantic interoperability. This is the tricky one. Do they understand the actual meaning of the data in the same way?
Meaning? How so?
Well, imagine one system records temperature in Celsius, another in Fahrenheit. Semantic interoperability ensures they both understand that data represents the same actual temperature, maybe by converting it correctly.
I see. So it's not just reading the data, but interpreting it correctly across systems. Okay, so how is this testing actually done? What's the process?
It usually kicks off with defining the project scope, figuring out what needs testing, setting up the infrastructure,
Laying the groundwork.
then setting up the test lab. And that's not just hardware. It's having people with the right skills, the right automation tools, a database to track configurations, ways to record metrics.
Sounds pretty organized. What's next?
Developing the test plan. This is key. Writing down exactly what gets tested, how it gets tested, the specific procedures, and setting up monitoring.
And then the actual testing.
Yep. Execute the plan, run the test cases. If something breaks, you dig in to find the root cause.
The detective work.
Pretty much. And documenting everything is crucial, keeping detailed test logs. Finally, you analyze the results, often with those automation tools, figure out what worked, what didn't, and free up the resources.
Okay. The articles mentioned examples like testing if different vendors' devices connect via Bluetooth.
Exactly. Or checking if network packets are sent and received correctly, if data is handled right at different technical layers, or if the core algorithms work properly when systems interact. It often boils down to a simple result. Okay, not okay for each test case.
Simple outcome, but complex process. Does it have any drawbacks, this test?
Yeah, it definitely has challenges. Pinpointing the root cause when multiple systems are involved can be tough.
I can imagine.
Accurately measuring how well they interoperate isn't always straightforward either. And as systems get bigger and more connected, testing scales up massively, network complexity adds another layer.
More moving parts.
Right, you even have to test your test equipment. Plus, documenting everything well and dealing with requirements that might not have been clear enough initially, it's demanding.
It sounds like it. One last thing the sources mentioned, conformance testing. How's that different?
Good point. Conformance testing is about checking if one product meets a specific standard. Like, does this phone meet the Bluetooth standard?
Okay.
Interoperability testing checks is different products, which maybe already passed conformance tests, can actually work together.
So one is meets the spec, the other is plays well with others.
You got it. That's a good way to put it.
Okay, so wrapping this up, the big takeaway seems to be that interoperability testing is absolutely vital. It's what lets all our different software and devices communicate and function together without causing us constant headaches.
Precisely. It's the hidden glue, really, making our interconnected digital lives work as smoothly as they generally do.
It really makes you appreciate what goes on behind the scenes.
Yeah.
Okay, here's a final thought for you. Think about all the digital tools and systems you rely on every single day. What are those hidden complexities making them all function together? And what would your experience be like if that interoperability suddenly failed? Something to ponder until our next deep dive.